fixed for a particular jaw. That is, I'm not going between jaws. Here I'm presenting a slide what I'm getting with changing the reference group as well as changing the values of the hyperparameters, trying to see how the credible intervals look like, and as well as changing the spatial grid. What I'm getting here is that as you change from CL to BOP, you have a lot of effect. Now this is going to happen because see, we accommodate the bleeding on probing, the binary indicator with the probit trick, and there is very little information in bleeding on probing. So changing the reference group from CL to BOP would have some kind of influence on the credible intervals. But overall, on the overall, what I find is that the sign of the coefficients and the subset of coefficients with intervals excluding 0 remain the same. So what I would say, what I would guess here is that that you do have something to consider when on the group that you choose for your identifiability, but we consider probit because it is very easy to do the MCMC. You can also do some other kinds of transformation, but this is what you get. I mean, there is some sensitivity when you change to BOP as the baseline group, but there is not much going in pocket depth. I mean, what is happening here is that it is getting much tighter, but the point estimates are not that shifting too much, but somehow. Finally, we conclude, I mean, based on all these things, what we get is that the data shows a strong relationship between the presence, absence, and the underlying process. If you account for informative absence, it improves the inference for the fixed effects and almost surely an estimation of the underlying process. Now, we have made several assumptions about the latent spatial process. We have considered normality. There is a single factor which we assume is influencing all the responses as well as the missingness component, and also a linear relationship. Now you can think about why are you considering factor. There are things, factor models, because we set on exploring with the fact that there should be something, a common latent disease status that is influencing all the process. There is another thing, there is another type of model. What you can do is called the multivariate CAR, where you can consider all the responses together in a multivariate framework and can model that. But factor model, if you believe that, if you believe what you are modeling is the right thing to do, because as you know that the pocket depth and attachment loss are not that different. They're the similar things, some measurements taken with the same probe. Even if it's the same probe that you are doing, trying to figure out all these things. So that made us go in this route, considering factor models. Now, the questions like how many number of factors, what are the choice of the number of factors, that can be challenging. Like if you want to now discuss about why it's one factor or then more than one factors, then it becomes to the number of factor choice problem. Reversible jump is one way to do. People have proposed it, but I'm not really sure how you can easily code it in a framework where there's this kind of a huge spatial domain. I mean, there are some related literature. I mean, some work by David Dunson who has done some kind of work. I'm not really sure with the context, but he told me in a personal conversation that he has some cute way of doing it, considering the number of factors. But then if you consider more than factors, how do you associate the linear relationship with all these different factors? So to keep things simple, we consider a single factor, believing that with the idea that single factor is predicting the whole process. We are currently studying robustness to this assumption and developing more flexible models from here. I mean, I want to mention here is that most of these things have a lot of measurement error. So the periodontal probe, if you dig into the mouth, if it records a 2.3, it is mandatory that you should not be recording 2.3. It would be either 2 or a 3 depending on the school you are in. I mean, there is some convention that you have to round it up or down. So all some measures here are round numbers. Now, if you think critically, then basically there is inherent measurement error. So we have not explored all those things here. Just it was a set for like setting foot into exploring whether there is spatial association that can explain the periodontal story. And these are part of future work which I am currently considering. As part of, I'd like to thank the grants that provide me support for doing this work. Thank you.